be normal. You won't even know it's happening. Okay, so we're going to start series today. How about your blue sheet as well as your notes? Okay, so on your blue sheet at the top, remember from 8.1 that sequences converge when you take the limit to infinity and get a number. All the rest on that blue sheet are going to be about series. So put a little note at the top or somewhere on there that the sequence converges when you take the limit and you get a number, any finite number. Okay, so don't forget about sequences. You can still tell if a sequence converges or diverges. You take the limit to infinity and you get a finite number. So you get something that's finite. Okay, so we're going to learn a few more things now for series. I'm going to do a few of the tests off of that blue page, and by the end of 8.6, you'll know everything on that blue page. So just to kind of recall, a series is when you're going to add up all of those terms, and the sequence is just the individual terms. Okay? What does this symbol right here mean? Summation, to add. Okay, so that's what it's telling us to do. This says to start at the first term and to go into the infinite term. Okay? So let's just kind of understand this concept first off. If I was to add all of these together, that'd be 0.1 plus 0.01 plus 0.001, etc. What would that end up looking like? 1, 1, 1, 1, 1, 1, 1, repeating forever and ever and ever, right? And what do we know that's equivalent to? 1 9. Okay? So I could say, if this was written somehow as a series, I could say that the sum converges to 1 9. Okay? That's what it means for a series to converge. What about down here? 1 plus a half plus a fourth plus an eighth plus 1/16. This is a really basic one. I told you guys a joke about this. Did I tell you this joke? Math professor walks into a bar, orders 1 pop. The next one comes into a bar, orders half a pop. The next one comes into the bar, orders a fourth of a pop. The next one goes into the bar, orders 1/8 of a pop. The next one goes into the bar, orders 1/16 of a pop. And the bartender says, "Stop it! And just order 2 pops." Because how does it compare? Now you get it? Yeah. Okay. I'm just lazy. Alright, so this would be 2. Again, this is what it means to converge. You get a finite sum. If I was to add 1 plus 2 plus 3 plus 4 plus 5, what would that be? Infinity. Does this converge? No. Okay, so that would be a series that would be divergent. So it only converges, it's decreasing. I can't promise that. No. Okay? Usually. Okay? But just because it's decreasing doesn't mean it's convergent as well. Okay. Alright. So let's look at this first example. This is now written as a series with the whole summation part instead of just the terms being added. Let's go ahead and write out the first few terms and see what happens. So if I plug in 1, I get 1 minus 1 half. So that's my first term right there. I plug in a 2. Okay, so that would keep going and going and going, right? What do you notice happens? negative a third plus a third. They cancel, and then what's going to happen with that negative fourth? It's going to end up canceling. As soon as you see you've got a double cancel, like both of those terms are canceling, you pretty much know that all the rest of the terms are going to cancel. Okay? So if you have anything left over, that's part of the it converges, it's part of the sum that it converges to. So all of this, because the rest of those cancel, converges to 1. Okay? Because basically you're left with that infinite, like that very last term, or sorry, not plus, minus 1 over n plus 1, where this goes to infinity, right? Which is just going to be 0. So you're left with 1. Okay, with that last term. Okay? As you find infinity, which you can never do. So we're going to say this converges by, what is this series going to be called? Whenever the terms start canceling out like this is called a telescoping series. You are always going to have to tell me what series you are using. Always. Okay? You have to name it. Okay. So looking at this next one, it's kind of like the whole chapter a little bit, only for this part. What happens down here? What can you do with the denominator? What is it easily? You can factor it. So whenever I see that I can factor the denominator, I want to think partial fractions, which will lead, hopefully, to telescoping. Okay, so put that in your notes. Kind of like, when I see that I can factor the denominator, I want to think partial fractions. Because you're going to have all of these different ways that start creeping up on you. So when you see factor denominators, you think what?
Partial fractions.
Okay. Partial fractions, telescoping. So go ahead and do this partial fraction. You can do this. You guys all know how to do partial fractions. I'll write up what you should get, and you'll see if you get the same. So I'll let you see if you get that. Okay. Anybody need more time getting here? So now that I have the partial fractions, I want to hopefully think telescoping. So let's write out the first few terms and see what happens. Now in your homework, there's going to be some you will have to write out more and more terms, okay, until you see a double cancel. So in this case, I see the 1/3 cancel. I see the 1/5 cancel. So here I've kind of got that double cancel, so I know that the rest will end up canceling out. All right? So what does this equal? this converges by telescoping. Yep. All right. So tell your neighbors again when you see factored. What do you think? Okay. And write that on your blue sheet because I don't know if that's, is telescoping on there? Do you want to write any hints with it? Kind of little notes to yourself? Okay. So when you see like denominator factor, think to use that telescoping, partial fractions. Okay. Make your notes on that so that you know. All right. Next, we're gonna do geometry. Geometric, you have an A, an R, and your N. N is just like to tell you what terms you're doing. What is A? It is a constant. It is actually, though, your first term. Okay, so A is that first term. What is R? Yeah, change the way, what are you doing with it? Yeah, that you're multiplying by. Okay, so R is that multiplier, what you're multiplying by each time. Okay? So dot ratio that you are going to multiply with. Okay, so let's think about this. Let's say that A was 2, and I started multiplying it by 3/2. What happened? Did it get bigger or smaller? Bigger. And let's just say, then I took that number and I multiplied it again by 3/2. What happened? Got bigger, and I multiplied it by 3/2. What happened? I got bigger. Okay, but let's say I started with the 2 and I multiplied by 1/2. What did it do? It got smaller, and I multiplied again by 1/2. It got smaller, and then it gets smaller and smaller. So, I mean, John was asking, not always, but if I'm going to kind of think logically, when the absolute value of R is bigger than 1, what happens? For geometric, it diverges. When the absolute value of R is less than 1, but greater than 0, kind of like this guy, what's going to happen? For geometric, it will converge. Okay? Okay. Not only do you get to know if it converges or diverges, you get to find what it converges to by the magical formula A over 1 minus R. But, get ready to yell at everybody in your group. You ready to yell? Okay. This is me yelling. N has to be 0. Yell at them. Star it. Put big old arrows to it. Yell at your neighbors. Do it. N has to be 0. 0. So for geometric, 0. Okay? For geometric, to find the sum, N has to be 0. And I put a little exclamation point because I feel like I think that's factorial. 0 factorial is actually 1. Right? Okay. So, for geometric to find the sum, N has to be 0. Now, just to tell if it converges or diverges, N can be anything. Okay? So just to tell if it's convergent or divergent, I don't care what it is. But if you're going to find the sum, it has to be 0. Tell your neighbors that. Does it have to be to tell if it's convergent or divergent? All right. So, let's look at this one. Okay. What's your your R? What does that mean? Diverges. Diverges by what? What is this called? Geometric series. All right, let's look at this next one. What is your R? 2/3. So what do you know it does? Converges. Oh, I know, but hold on. Converges by geometric series. I don't care where it starts to tell if it's convergent. It can be a million for all I care. Okay? So this tells me it's convergent. Now let's find the sum. What does it converge to? I have to make it start at 0. Holy moly. Alright, how is this going to work? How am I going to change it? Well, let's just first think. If you've got it, great. Just wait if you've got it. If I start plugging this in here, if I plug in a 1, I'm going to be at 2/3. Plus, if I plug in a 2, I'm going to be at 4/9. Plus, etc., right? So when I plug in a 0, I need it to be at 2/3 for that first starting point. So 2/3 to the 0 is that at 2/3. So what am I going to have to do? Plus 1. Because now when I plug in a 0, I'm actually at 1. When I plug in a 1, I'm actually at 2. Okay? Alright. Now is it set up for geometric? Do you have your A and your R to the end? No. So you're going to have to adapt. We're going to use some exponents. How can I rewrite 2/3 to the n plus 1? Very good, Sarah. 2/3 times 2/3 to the n. Now you have your A, and you have your R. So see if you can find the sum. A over 1 minus R. Yes.
Like if you say you just change it to 0 and it's still 2/3 to the n. If you get that, then you know it's 3. Well, can you just take the 0 minus it from 0?
Yes, you can do that as well. Yes, always. Okay. So if you think like that, sweet. Okay. Did you guys hear what she said? Why don't you explain it?
Well, the way I did it was I just automatically changed n equals 0, so I did 2/3 to the n, but then from 0 to infinity. And then you can do the a over 1 minus 1 thing, which equals 3. And then you just minus the 0th term, which is 1, and you get 2.
So you could have actually, yeah, so if you wanted to, fine. If you could have actually started here, found the sum with A over 1 minus R, and then you still had to add on the 0th term. I think that's more confusing. Okay? And a lot of times I may even just ask you to say, what's an equivalent series? And you have to adapt this to look like this. Okay? So that's why I always like this as well. Alright. This is so cool. You're going to be so excited that you came to school today. Are you ready for this? This is so cool. Okay, so think back in one of your algebra classes, or even in math analysis, or whenever you can remember it last. So when you thought about what a rational versus an irrational number is. Okay. An irrational number versus a rational number. Okay, so rational numbers are decimals that what? Terminate or repeat. And why are those rational? because you can turn them into fractions. Okay, you guys are so smart. See? So this is a repeating decimal, and you were like, when you learn that, you're just like, okay, I believe you. You are going to turn them into fractions today. Any repeating decimal, I'm going to show you how to turn it into a fraction. This is cool. This is so cool. You're going to be like, yes, I'm so glad I'm here. Okay? All right. So what you're going to do is kind of break it apart in the repeatings. Okay? So like all the little parts for repeating. That's going to get it for you. Are you sure?
Yeah.
Okay. All right. So let's look at the first one. Let's write this as a fraction. This would be 15 over, and I'm going to use tens to kind of help myself out. This would be 10 to the what? Square. That's 15 hundredths. So that's for the first one. Let's do this next one. This would be 15 over 10 to the fourth. This would be 15 over 10 to the sixth. 15 over 10 to the 8th, etc. And what are we doing with all of those to get to the repeating decimal part? We are adding them. Okay. So now, what is your A? What is your first term? 15 over 10 squared. That's your first term, right? What is your ratio that you are multiplying by each time? Close. 1 over. So 1 over 10 squared. So now can you set that up with the summation part? Go for it. Set it up with the summation part. Where do you have to start? Middle. A. R. Did everybody get that? Okay. Now, go find the sum. Sum is A over 1 minus R. Put it in your calculator. Go get your minds blown. Let's see. What's Ernst? See how each time, if I multiply by 1 over 10 squared. Go ahead, John. You can explain it. Yeah, go ahead. Are your minds blown? You're just like, oh my god, I'm so glad I came to class today. And you're repeating decimal, you can make it into a fraction. I know, right? Okay. It's like magic. Magic. Are you good? Okay, you heard me. You ready?
Yeah.
All right. This is called the in-term test. And it's this part right here. Okay. This test can only show divergence. Okay? Now, at the beginning, this says, hey, if it converges, then this limit is 0. Does it say if the limit is 0, this converges? No. Okay? So I actually never even pay attention to that because it's kind of confusing. Okay? The only thing you can say is if the limit is not 0, then the series diverges. If the limit is 0, then you have no idea what's going on still. You have to do something else. Okay? Alright, so let's look at this first one. And you can write on your blue sheets again, this is called the nth term test. That's what we're going to call it. I think it's the very first one. Yeah. And I call it the nth term test. Alright, so let's take the limit. As n goes to infinity of 2 to the n. Starkey, what do you get? Still ready. Alright, I'll wait. Go ahead, let him do it. Infinity. Hey, is that 0? It's not 0, so what can you say? The sky diverges by the nth term test. Sweet. Isn't that nice? Yes. That's the language. That's why I use it. Okay. Alright, let's look at this next one. I'm going to take the limit. That goes to infinity. Starkey again. Bigger on top, bigger on bottom, or the same? Very good. These guys are the same. So it's growing at the same rate. So I'm going to take the leading coefficients, which would be 1/2. And 1/2 is what? Not 0. So this guy diverges by the nth term test. Next one. Sarah, what does that equal? Oh, it converges at 0. No, you cannot say that. So all we know is, like, we don't know, actually. Okay? So the nth term test fails. That's all we know. We don't know if it diverges or converges still. The nth term test fails. Use another test to be continued. Is that what this sheet is for? Okay? All of those tests. So right now, the nth term test has failed. You're going to learn this one actually tomorrow.
Oh.
I put it on my door actually. Really wow. You drink coffee, see?